Assalamualaikum warahmatullahi wabarakatuh. Introducing, my name is Helmarini Endang Fepti with student identification number 121230195 from Department of Chemical Engineering. In this chance, me as the speaker of Group 9 will discuss a bibliometric analysis of graviton theory in modern theoretical physics using VOSviewer. The content that will be discussed in this PowerPoint includes abstract, introduction, objectives, experimental design, result and discussions, and concluding remarks. The search for gravitons has become a focal point in scientific discourse as researchers strive to validate their existence using Albert Einstein's general theory of relativity. The detection of gravitons in the field presents a significant challenge due to their low energy and mass. Despite efforts to reconcile the theory of relativity with gravitons over time, discrepancies between the two have persisted. The intricate interactions of graviton particles pose a challenge in research, but some formulations of gravitons are feasible. It has been understood for some time that massless graviton existence can appear in low-energy spectrum of various condensed matter systems such as the 4D quantum Hall system, quantum nematic crystals, and experimental proposals for qubit models. Hence, this study aims to analyze graviton's theories from 2004 to 2023, employing bibliometric methods. Bibliometric data were obtained from Scopus utilizing keywords such as the standard model, gravitation, models of quantum gravity, gravity, and models of gravity. This study presents a comprehensive overview of the most active authors and esteemed institutions in journal publishing. Utilizing VOSviewer software, this analysis provides an objective evaluation of research trends spanning from 2004 to 2023, with particular focus on the most noteworthy topics. Journals accounted for a total 1,739 publications, with 623 publications covering the significant topics. Massless graviton is a concept that occupies a central position in the discussion of the modern theoretical physics. The fact that causes this case is the formulation of gravitons resembles gravity in a higher dimension. Although gravitons do not have any gravitational interactions, there is a connection that is known as general relativity by Albert Einstein. Studies have been attempted to explore this theory that is related to massless gravitons. The gravitons are massless because the distance between gravitational forces is quite far. It must be said that gravitons are bosons with spin 2 because the source of gravity is the energy tensor. General relativity, as a classical field theory, describes the force of gravity in terms of interacting massless tensor fields. When these fields are calculated, massless spin 2 particles, called gravitons, appear. The masslessness of gravitons is generally considered to be guaranteed by the dimensional invariance of general relativity. However, it is also known that gauge invariance does not necessarily imply zero mass. Quantum effects from other fields, for example, can give gravitons mass without violating fundamental properties of general relativity. Recent research has suggested that not all gravitons theories are consistent with the general relativity theory. One of the main issues in gravitational theory is understanding the formation of black holes from the gravitational collapse of objects. Over the years, scientists have tried to connect the theory of gravitons with Einstein's theory of general relativity. This is due to the differences point of view between these two theories. According to the general theory of relativity, matter distorts the fabric of space and time around it and creates a force field effect that attracts each other. However, quantum particles move from one place to another. In this case, the particles are also known as gravitons. Some experts believe that gravitons exist, but not everyone agrees. There is no theory that successfully unites quantum theory with general relativity has been verified. This led to suspicions that quantum theory predicts that gravitons have such a low mass that their presence is undetectable. Studies of gravitational waves from black hole collisions show that gravitons have a lower mass than electrons. However, such a singular final state of graviton matter is clearly incompatible with the principles of quantum physics. Another reasons why gravitons are still hypothesized by scientists is because their interaction of or couplings of gravitons are varied and more complex. There are infinite number of types of graviton interactions. Despite the complexity, is it possible to formulate a quantum mechanical graviton interaction, but it requires a lot of process because graviton interaction is weak. The calculation was done with Feynman's rules and Feynman diagrams in the process. Feynman himself gave the formula for the gravity, and it seems that the formula and calculation have never been published. Some people also use the formulation to explain the process of gravity and gravitons. It has been known for some time that there may be massless graviton existence appearing in the low energy spectrum of various condensed matter systems such as the 4D quantum Hall systems for experimental proposals, qubit models, and quantum nematic crystals. Next step, what is effective field theory describes these emerging gravitons interactions. The conventional conjecture is general relativity. These issues of the existence of gravitons became a focal point of scientific discourse. The field of the journal is limited by the publication period of time from 2004 to 2023. The data was retrieved from Scopus database in October 2023. This data was analyzed to be able to describe the existing information. The development of the graviton theory topics was analyzed using the VOSviewer software to generate the occurrence of the title terms that was published at once. The keyword used in the Scopus database search was title apps key graviton theory with year intervals ranging from 2004 to 2023. The search proved with 1,739 publications on graviton theory. The selected data was converted to RIS format. The information contained in RIS format was used for visualization of similarity using VOSviewer software. Additionally, this study employs an experimental design to describe and explain variation in information gathered on graviton theory. The data collection process draws from Scopus, which reflects the number of publications per year. This data then analyzed using Excel and RIS format in order to map various types of bibliometric analysis, ultimately resulting in the creation of a main bibliographic database is obtained from RIS format. Move on to the document characteristic and year of publications. A total of 1,739 journals on graviton theory have been published in the last 21 years with 8 different document types. Out of these publications, 1,429 articles were the most frequently published articles, followed by 233 conference papers and 40 reviews. 21 book chapters, 15 conference review, 5 term papers, 1 short survey, and 1 erratum were published occasionally. The figure 1 illustrates the temporal trend in publication on the theory of gravity in modern physics. The number of publications was modest in 2004 with approximately 55 publications. Subsequently, the number of publications gradually increased, reaching the peak of 48 publications in 2020 and declining to 42 publications in 2022. Researchers' interest in graviton theory is on the rise. Although it remains relatively low, this presents vast opportunities for graviton theory publications. In 2005, there was a surge in journal publications, amounting to an increase of 27 27 publications. However, between 2005 and, and 2010, there was no significant change and stagnation was observed. Journal publications spiked again to 31 in 2011 but witnessed a decrease of 17 publications in 2013. During the time frame of 2015 to 2018, there was a growth in the number of journal publications. However, in 2019, there was a decline of 41 publications. And once again, in 2023, a decrease in publication was observed. There are 1,739 publications on Graviton theory in the last 21 years, contributed by 159 institutions from 81 countries and one undefined country. We show the top 30 institutions contributing the total publication compiled from the Scopus database. Over the past 21 years, France's NCRS, Centre National de la Recherche Scientifique, ranked first with 173 publications, followed by the Science and Technology Facilities Council with 279 publications. This is followed by the U.S. Department of Energy from the United States and the Universidade Estadual Paulista Julio de Mesquita Filho from Brazil with 7 and 6 publications respectively. The figure shows data that English is the most common language used for journal publication. There are 1,738 journals in total, followed by one Chinese journal publication. To get an idea of the most productive authors, we rank them by total publications on Graviton's theory research. According to the data obtained, images on the slides show that the authors collaborate on joint publications. When co-authors have similar research interests, they are more likely to publish articles together and refer to each other. For example, Mukoyama, De Felice, and Tanaka conducted research together. The green circular figure shows that author Tanaka has the most documents with 15 documents. Over the course of 21 years, we identified the top 5 influential publications related to graviton mass from X-COP galaxy to gain an understanding of their impact. The figure displays that Journal of High Energy Physics ranked first with a total of 419 publications, making it the most significant publication title in the graviton theory for the past 21 years. The findings demonstrate that the Journal of Energy Physics have been a dominant source of graviton theory publication, followed by Physical Review D Particles, Gravitation, and Cosmology with a total of 218 publications, followed by Physical Review D and Physics Letter Section B Nuclear Elementary Particles and High Energy Physics, which have 139 and 88 publications respectively. The table shows that publication distribution of graviton theory in modern theoretical physics research domain by top 10 subject areas. Physics and astronomy occupies the first positions with the highest number of publications after engineering with 1,649 publications and 102 for engineering. Then followed by mathematics and multidisciplinary with the number of journal publications 72 and 60. It is also shows that the total percentage of physics and astronomy publication is 83.92%, engineering 5.19%, and mathematics 9.66%. The figure shows the publication distributions of gravitation theory in modern theoretical physics research domain's top 10 keywords. Bibliometric data were obtained from Scopus utilizing keywords such as the standard model, gravitation, models of quantum gravity, and models of gravity. Based on the data from 160 keywords collected to the top 10 of publications can be seen in the figure. Models of quantum gravity are the most distributed with 130 journal publications, followed by gravitation with 123 journals. Term occurrence analysis was conducted using VOSviewer software to provide an objective overview of research trends between 2004 and 2023. Specific research interests were highlighted using a list of keywords extracted from relevant publications. The figure displays the term occurrence network, where each circle size correlates to the number of term users in the publications. The analysis produced 150 items organized into 5 clusters, resulting in a network of 2,230 links with a total of 5,686 connections. The Graviton theory demonstrates potential for verifying the existence of the theory in modern theoretical physics. Such potential is evidenced by frequent mentions of terms like modified gravity, gravitation, models of quantum gravity, and the Standard Model. The gravitation theory demonstrates potential for verifying the existence of theory in modern theoretical physics. Gravity plays a crucial role in connecting this theory. Cluster 1 is marked in red and 44 items were found. The largest red circle has the term the Standard Model, which has 80 links and 365 links in total, and 57 occurrences. This term has close contact with the terms extra dimensions and gravitons, which indicates that the three have a close relationship with each other. And the study states that the general relativity is still separated from the world of quantum physics for its extraordinary success. One approach that could potentially connect general relativity and quantum gravity is in the optical mechanical analogy in general relativity. Cluster 2 is highlighted in green and 44 items were found. The largest green-colored circle with the term gravitation has 110 links, 623 total strength, and 123 occurrence. This term relates to physics gravity, where gravity is for objects of mass to accelerate towards each other. Gravity is one of the 4 fundamental interactions in nature, the other 3 being the electromagnetic force, weak nuclear force, and strong nuclear force. Gravity is the weakest of these interactions, but it acts at great distance and is always interesting. Cluster 3 is marked in blue and has 44 items. In this cluster only displays the largest circle and has the most links with a total links of 24 and a total link strength of 203 with an occurrence of 130, seen from the figure. The term of quantum gravity model has the largest circle. The quantum gravity model is an attempt to unite the principles of quantum mechanics with the general theory of relativity with the explanation of gravity on a large scale. Next, cluster 4 is characterized by the occurrence of a yellow circle and has 26 items, and the largest circle displays the term articles with 55 links, a total link strength of 216 and 39 occurrence. This term related to the studies discussed and shows that there are still many discussions but only hypotheses. This article is also related to gravity, gravitons, relativity, and others. Cluster 5 is marked in purple and 7 items were found. In Cluster 5, the circle is very small and has fewer links than the others. It can be seen that in Cluster 5, a large circle appears and the term modified gravity appears, which has 18 links, a total link strength of 54 and 47 occurrence. This cluster has a few number compared to the other clusters. Modified gravity is an attempt to change gravity with a desired formulation. It is interesting to investigate the interaction of the combination of modified gravity and hypothetical interaction between dark energy and matter. For example, the Newton star model in modified gravity is widely considered in the study. And finally, the conclusions. This study shows bibliometric data from Graviton model research. The standard model of Graviton of gravity for 21 years in the period of 2000 to 2023. This analysis was taken from the Scopus database, which is widely recognized by researchers as a provider of standardized information. The results show that during the 21 years of journal publications on the standard model of graviton on gravity experienced instability between 2004 and 2023, but from 2011 to 2018, it was stagnant. Perhaps at the time it was a trend. In 2004 to 2011, only slightly increased. Graviton model research is on the great interest in the United States with 511 publications. Even so, the existence of this graviton model is very small because the discussion in journal studies are still unfamiliar about gravitons because their existence is still hypothesis. Besides, there Besides that, there is an institution called NCRS, Centre National de la Recherche Scientifique from France, with 173 publications. This study is useful for understanding research trends on gravitons model and provides developments for research on the existence of gravitons that are still unknown. That's all from Group 9 about gravitons. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.